Two small conducting spheres A and B are identical. Each is given a charge of 8 into 10 to the power of minus 7 coulombs and placed in air at separation between, and the separation is 0.5 meters. Now a third identical uncharged conducting sphere is brought in contact with the sphere A, then brought in contact with sphere B, and finally taken away from both. Calculate the final force of repulsion between A and B. So here you have charges A and B, which has initial charges 8 into 10 to the power of minus 7, and they are separated by a distance of 0.5 meters. Now you have third identical uncharged conducting sphere C, which is first in contact with A and then in contact with B. And then after all this is happening, what is the force of repulsion between A and B? So here you need to understand the charge sharing pattern. So whenever you have two charges paired together, they share the charges. So the initial charge Q1 or QA for charge A is 8 into 10 to the power of minus 7 and QC equal to 0. But when both of them are in contact to each other, they share the charge, which means that the new charge for A, QA dash, becomes QA plus QC upon 2, which is the same for QC as well. So the change QA dash is equal to QC dash, but since we are supposed to find the repulsion force between A and B, we are concentrating only on A. So which means that 8 into 10 to the power of minus 7 plus 0 upon 2, and you would get the value of 4 into 10 to the power of minus 7 coulombs. Now what happens with charge B? Now with charge B, QB dash equals QB plus QC dash. So QC already has some charge associated with it. So that is nothing but this charge. So what is QB? QB is 8 into 10 to the power of minus 7 plus QC dash is nothing but 4 into 10 to the power of minus 7 and that upon 2, and that will give you a value of 6 into 10 to the power of minus 7 coulombs. So you now know the new values of QA dash, that is new charges of QA and new charges of QB. The force of repulsion between A and B is always given by the Coulomb's inverse square law, which is given by F equals 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Now we are supposed to find the values after the contact of charge C took place. So you have 1 by 4 pi epsilon 0 given by 9 into 10 to the power of 9, and the new values Q1 equals QA dash and Q2 equals QB dash. New values are given by 4 into 10 to the power of minus 7 into 8 into 10 to the power of minus 7, and the distance R was given by 0.5. So if you do 0.5 square, you should be able to get that answer. So if you do point square, from here you would see that 9 into 10 to the power of 9 into 4 into 8 into 10 to the power of minus 7 into 10 to the power of minus 7 divided by 0.5 square is 0.25, and you get that as 25 upon 100, which means that the 100 should go up. And you get 8 into 24, which is almost close to 25, but less than 1. So you should get a value somewhere close to 8.7 or something, 8.7 or something, and then rest is up to the numerical. From a power perspective, you have 10 to the power of 9 and 10 to the power of minus 7 and 10 to the power of minus 7 and 10 to the power of 2, which is going up because of this 100. So you get 10 to the power of 11 into 10 to the power of minus 14, which implies you get somewhere close to 8.7 into 10 to the power of minus 3.